3.1, the next method we're going to look at is solving by graphing. And so what this means, literally, we're going to graph both lines on the same grid. Now, we've talked at length about how to graph lines, okay? So you're going to have to take that prior knowledge and you're going to have to put it to use. So we're going to graph both equations, both lines, on the same grid, okay? Then the point where the two lines cross is the solution. Now, as we learned Friday, sometimes the solution isn't just a point. Sometimes there's no solution. Sometimes there's infinitely many solutions. And I want you to see what those will look like, okay? Because they have a specific look to them. Then when we do have an actual solution, we're going to express that solution as an ordered pair or point like we did on Friday. That's not going to change. You can either take a picture of this page or you can screenshot it from your book. It is on page 357 in your book. Okay? There are some terms up here that you need to know. Okay? They will ask you to describe the types of solutions. Now, up top here, you'll see the descriptors, okay? If there is one solution, we call it consistent and independent. We use the word consistent to show that there is a solution, okay? If it does not have a solution, like the far right, we say that it is inconsistent. If it has a solution and there are infinitely many solutions, then we say that it is consistent and dependent. And again, I put the symbols down there for you if you wanted to use those, okay? We're going to go through examples today that will be one of each of these types, so you can see what it is that we need to do and what they should look like. What's important here, okay? If you notice, we have two lines that intersect, one point, one solution. On this one, this is actually two equations, okay? But both of those equations end up being the exact same line. And that's why you see down here where it says same line. And then, of course, parallel lines are lines that never, ever intersect, which means there is no solution. So we can kind of connect what we did on Friday back to some graphs and some visuals of what's happening with these systems of equations, okay? Now we're going to go through some examples. Okay, here's the first problem that we're going to go through. If you want to take a picture of this, and then I'm going to do all my work down in this area, and then I'm going to do my graphing over here. So if you want to take a picture of this and situate it in your notes, that would be fine with me. What's nice is that both of these equations are already in slope-intercept form. So all I need to do is identify the slope and the y-intercept, and I can graph them. So the first equation, what is the slope for this red equation? Slope for the first equation? 2. Y-intercept for the first equation?
1.
Slope for this blue equation? Y-intercept? -1. Okay, so I've gone ahead and written that out. Now notice I've written the slope as 2 over 1 and 3 over 1 because we're going to have rise and run in order to find the other point. Now at this point, if you want to go ahead and graph, you can. One thing I need to make sure is very, very clear. Your graphs, your lines should be as perfect as possible. Because when we find the solution, when we look for that point of intersection, if your line is off just a hair, it can throw your solution off. Okay? So you got to be very careful when you graph these. So go ahead and try to graph the red and the blue line on the same grid, and let's see what you end up with. So I'm going to graph the red line first. So the y-intercept is 1, which means I'm going to put a point here at y, where y is 1. So there's my y-intercept. Then from there, I'm going to go up 2, right 1, and put a point. Okay? And then I'm just going to connect those points to the line. So there's my red line. I color coded the whole thing for you. Now, what's interesting about my graph, and this may or may not be true for yours, is it's kind of hard for me to, with this stylus, put a point on this in this program just in the right place. But what I am able to do is make sure that the line goes through the grid points, the grid marks exactly. Okay? And you're going to really want to pay attention to that. You're going to definitely need to use a tool like what you can in Notability to draw perfectly straight lines. If you continue to try to draw me these sort of wavy lines, you're not going to do any of this right. Okay? So now let's do the blue line. Y-intercept is -1. I've got a point down here at -1. Since my slope is 3/1, I'm going to go up 3, to the right 1, and I'm going to get another point. Okay? Then I'm going to draw a line. And that's what you should have done. How many have something that looks like that? Okay, good. Then it's just a matter of identifying the point of intersection. And that point of intersection is going to be right there. 2, 5. That's the solution to this system. That's the final answer. Now, if you didn't get 2, 5, and your graph kind of looks like that, what's probably true is that your lines are off a little bit. And so one of the things that I want to point out about solving by graphing is that although we can make a good connection to what it should look like and what that point of intersection should be to what we did on Friday, it can often be very inaccurate because it requires perfection. All right? And when we get to our quiz, all right, you just need to know that I'm going to make it so that it should be fairly obvious where those points of intersection will be. You're just going to have to be very particular and pay very close attention to detail as you do this. This will take you a little bit of time. Okay? How many had something? How many actually had 2, 5 as the solution? Okay? How many were in the ballpark? We're close to it, but it wasn't quite there. Okay, good. So this next one, I want you to be more particular and more detailed. Are there any questions before we go to the next one? Okay, let's go to the next one then. Again, if you want to take a picture of this, you can. Oh, and it's consistent and independent. So if you're write that down. You're asked to describe them. Consistent means there is a solution. Independent means there is only one solution. If it was infinitely many solutions, we'd say consistent and dependent. If there was no solution, we would say inconsistent. Okay? Next problem. Again, if you want to take a picture of that, feel free. For this first one, what is the slope and y-intercept for the red line? 3/1, and what's the y-intercept? For the blue line. Okay, so now, before you even start to graph this problem, what do I know about lines with the same slope and different y-intercepts? They are parallel, okay? When slopes are the same, but the y-intercepts are different, they should be parallel, which means there is no solution. So, if I go ahead and do my graph, my y-intercept is 2, I go up 3, 1 for another point, connect those, have a line. Okay? For the blue line, the y-intercept is -2, I go up 3, right 1 to get another point, connect those, and I do in fact get parallel lines. Okay? So you can tell before you even graph whether or not what kind of solution you're going to have. Okay? If the slopes are different, you know the lines intersect. If the slopes are the same, either you get parallel lines, or if the y-intercepts are also the same, you get the same line. So in this case, there is no solution, so we see it as inconsistent.
What happens if it's the same line, isn't it?
And we're getting to it. Getting to it. How many had this right? Okay, good. Okay, we have one more example, and of course, this one's going to be the same line. And I want you to see it. But I'm going to do it a little bit differently than you would expect. Because this particular set of equations are not going to both be in slope-intercept form. And I want to show you how I would do that, or how some of you have showed me how you do it. Okay? So, go ahead and take a picture of that page, and then we'll work through it together. For the red equation, what's the slope for the red equation? -3/4. What is the y-intercept? 3. Okay. So there's my slope and y-intercept, and I put the negative on top with the 3. Okay. And I think I'm going to graph that one next. Yeah, let's graph that one. So I put a point at where y equals 3. Okay? Then I'm going to go down 3, right 4. You could have just as easily put the negative down here with the 4 and made the 3 positive. It doesn't really matter. But I chose to put it with the top. So I go down 3, right 4, and that's where my next point is. And I connect the points and I get my line. Okay? So that's the first one. That's the red equation, which is the red line. Now, I'm going to leave this equation as it is because I want, for some of you still struggling with this a little bit, I can use x and y intercepts to solve this too, okay, rather than putting it in slope-intercept form. And what some of you have showed me, I like. So I'm going to make a little table. I'm going to put 0 in for x, and I'm going to put 0 in for y. This will give me the y-intercept, and this will give me the x-intercept. Okay? So, for this first one, I'm going to plug 0 in for x. Okay? And I'm going to solve this for y. And what somebody showed me is that they just cover this up, because this is all just 0. So basically cover it up, and I'm going to do that for you right here. There it is. I just covered it up. It's gone. So what does y equal to? 3. Okay, I divide both sides by 4, y equals 3. So I have that point, my y-intercept. Do I plot it? Well, hold on. Okay, so now for the next one, when I plug 0 in for... Nope, I didn't plot it. Okay, okay, now this part gets covered up. Right, so like that. So 3y equals 12. What does x equal? Sorry, 3x equals 12. X equals 4. Okay, so now I plot both of those points. 0, 3, 4, 0. They are. Okay, when I connect those points, what's going to happen? You get the exact same line. Okay, which means, what are my solutions? Infinite number of solutions. Okay? You can just put the infinity symbol if you want, yes. Infinite number of solutions, consistent and dependent. Now, if you were to have put this equation into slope-intercept form, what you would have found is that the slope and the y-intercept were exactly the same. And when that happens, you know you're talking about the exact same line. Okay? So again, that's the difference. When the slopes are the same, either it's the same line or they are parallel lines. In this case, it's the same line. And I can arrive at that in different ways, whether I use slope-intercept form, like this, or if I use the x and y intercepts, like I did down here. Obviously, the lines are on top of each other. It's the same line. You can't even see the red line anymore. It covered it up. Okay? So those are the 3 types of problems you're going to run into when you try to solve by graphing. Like I said, it's not always the most accurate way to come up with solutions. However, the connection between the solution and the visualization of it, I think, is really important. And you do have to know how to do both on your quiz and your tests. Okay? Any questions?
Is that it?